Hey everyone, welcome to The Explainer. Today, we're actually just going to take a deep breath and look at a concept that completely surrounds us, but we honestly rarely pause to appreciate. And that concept is preparation. Now, if you're a college student, you probably hear that word a lot, right? Preparing for exams, preparing for your career, preparing for the rest of your life. It can feel heavy. But today, we are definitely not doing a lecture. Instead, we're going to look at the concept of preparation through the lens of chemistry. And I promise you, it's actually an incredibly calming way to think about it. So let's just dive right in.
I want you to take just a second and ask yourself, have you ever wondered how really complex things actually begin? I mean, whether it's a towering skyscraper, a super complex piece of technology, or even your own long-term life goals. Everything monumental starts with very simple foundational pieces. It's really just a matter of putting them together in the right order. Well, in chemistry, preparation is literally defined as the methodical synthesis of simple parts into complex, meaningful structures. You can think of it kind of like a recipe. Chemists take these very basic, raw materials, and step by step, they build something entirely new. And understanding how they do this can actually offer a really comforting perspective on how we build our own lives. Just one study session, one assignment, one small step at a time. So, let's look at our first area, preparing to soothe, specifically looking at the synthesis of medicine.
Let's start with something we can all relate to, right? Paracetamol. It's a small organic molecule that's synthesized to treat mild to moderate pain. If you've ever had just a massive headache after staring at a textbook or a laptop screen for hours on end, a simple dose of this brings relief without knocking you out. But that relief doesn't just magically happen. It is the direct result of careful, quiet chemical preparation.
There's actually this really peaceful, almost predictable rhythm to the laboratory work behind this. First, you just suspend a powder called 4-aminophenol in water. Then you gently add ethanoic anhydride and, well, you just stir. You filter out the resulting solid, and finally, you dissolve it in warm water and cool the flask in ice until these pure crystals form. There is absolutely no chaos here. It's just simple stirring, filtering, and cooling to create medicine. And the real magic here happens quietly, right at room temperature. By simply combining those two basic raw materials, the 4-aminophenol and ethanoic anhydride, they form an amide bond. That yields paracetamol with just a little acetic acid left over. You've literally prepared a soothing final product just by letting simple things connect.
All right, moving on to our second concept, preparing to build. This brings us to the creation of polymers. You can think of polymerization as practically the ultimate act of building. It's the process of linking a huge number of smaller, individual molecules, which we call monomers, together to form massive, durable macromolecules. And honestly, this is exactly like your degree. You don't learn everything on day one, right? You link knowledge together step by step, chapter by chapter, until you've built a strong, unified foundation.
For example, consider how we prepare polyvinyl chloride, or PVC for short. You actually start with just a simple gas, ethine. By treating it with hydrogen chloride, you get vinyl chloride. Then, heating it with a catalyst links those units together into a long, continuous chain. And that final product? That's the sturdy plastic used in the pipes of your dorm room or the insulation around your laptop charger. It's just a steady build from a simple gas to a solid, everyday material.
Now, there are basically two main ways to build out these chains. Addition polymerization is kind of like a really fast chain reaction where molecules just add on to each other with absolutely no leftovers. It's rapid and it's exact. Condensation polymerization, on the other hand, is a much slower step-by-step growth. As the functional groups link up, they actually release simple molecules, like water. Both methods require an initiator to get started, but they really show that sometimes growth is super fast, and other times it's just a slow, steady, step-by-step process.
Let's zoom in even further for our third section. We're looking at preparing the future through the assembly of nanomaterials.
If we look past the plastics in your room, down to the invisible, atomic scale, we can see how preparing materials is quietly shaping the technology of tomorrow. In the world of nanomaterials, there are essentially two philosophies of preparation. You have top-down fabrication, which is a lot like carving a statue. You take a bulk material and carefully cut or mill away the excess until you get your tiny nano-sized particle. Then you have bottom-up fabrication. This is where you patiently build from the ground up, literally atom by atom or molecule by molecule, using processes like a sol-gel method. I think it's a great reminder that sometimes you have to strip away distractions to find your focus, and other times you just have to build your knowledge one tiny piece at a time.
To actually prepare something like carbon nanotubes, chemists use what's called the electric arc discharge method. Basically, by passing a massive electrical current between two graphite electrodes in a gas-filled chamber, the carbon actually sublimates. In this incredibly intense high-temperature environment, the carbon atoms naturally rearrange and roll themselves up into these microscopic, perfectly structured cylinders. I know it sounds intense, but the outcome is incredibly elegant.
So why does this super intense preparation even matter? Well, it's because of the properties you get as a result. These nanotubes have an unbelievable tensile strength of up to 100 gigapascals. That means they can withstand extreme, and I mean extreme pressure without deforming. When I was reading this in the source material, I couldn't help but see it as a really comforting metaphor for resilience. Through careful, precise preparation, even in really high-pressure environments, you can build something inside yourself that withstands immense stress without breaking.
Which brings us to our final section, one step at a time, the real art of preparation. Let's bring this all back down to earth and directly back to you. The absolute crucial point I want you to take away from this explainer is actually quite simple. Great strength comes from simple bonds formed over time. Whether it's a medicine quietly synthesized in a flask to soothe a headache, a long polymer chain forming the pipes in your walls, or a carbon nanotube built atom by atom to resist massive pressure, the absolute strongest, most reliable things in our world are built methodically.
Like a strong polymer, your future is built one small bond at a time. I really want this to be a completely low-pressure takeaway for you today. Your academic journey, your exams, your career, none of it is just one giant leap. It is a steady, step-by-step synthesis. You really don't have to have the entire macromolecule figured out today. You just need to focus on the very next monomer.
So, that brings us to a question I'll just leave you to ponder. What small bond will you form today to prepare for tomorrow? Maybe it's just reading one chapter. Maybe it's just turning your phone off and getting a genuinely good night's sleep. Whatever it is, trust in the process of your own preparation. Thank you so much for joining me on this explainer. Take a deep breath, and I'll catch you in the next one.